So we've talked about a lot of like things that are unrelated to Android, right? We're really digging into Bitcoin, Bitcoin Dev Kit, the way sort of like the model for what it uses, and Electrum servers, PSBTs, output descriptors. I want to start talking about Android a little bit more. But before I do that, I want to say that the app that we're building right now, the Android app we're building right now, the end user for it is really the developers. So folks that are trying to learn the Bitcoin Dev Kit API. So that's the purpose of the Sobi wallet, really. And that's very different than the end user, which would be the person sort of using the wallet to make transactions and whatnot, right? And that's a fundamental difference, and is one of the reasons why you'll find in the wallet there's like some bugs or some like stuff that in theory you'd want to polish for. Say you don't have a network connection right now, it'll just crash. Rather, in a more polished app, you want to have a lot of checks and things for these corner cases, and different Bitcoin checks and bug polishes. I find the problem with those is that they create code bases that are really, really full of stuff and very hard to parse from a beginner's perspective. And so our idea here with this this code base is to create something that is easy for the end user to use. And the end user is the developer. So you guys are there to learn this code base, and that's how I built it, is for people who were using it. So the UI, the beauty, how beautiful it is, or the transitions between the screens, all these kinds of things are a bit rough around the edges. And the purpose is to keep it really light of all of the Android stuff that would make it a really beautiful app, but very hard to parse. If you're looking for beautiful native Android apps, I've got really good recommendations. So you should definitely look at those. And but the purpose of the workshop obviously is to go through the Bitcoin Dev Kit. And so just like looking at, if you want to see a Lightning app, you can look at the Phoenix Wallet app, for example. It's a native Kotlin application, or just Bitcoin, pure Bitcoin on chain. You could look at the Samurai wallet, which is written in Java, but is still Android native. But those are very, very hard to go through, these applications, because they're full of other stuff. And that's not the goal here. So the end user for these apps are really the people using the app. And here our end user is the developer. That being said, the code base can still be made better, right? We're trying to dance the dance of like making it simple to use as a developer, to understand it, yet providing something that looks like an application, right? This is an ongoing project. I invite you to have a look at the code base, and if over the course of the week or the next few weeks you work on some of the things and you think something could make the app better, please consider opening a PR on this particular repository. I'll be happy to review it. I don't want you to think that I would merge anything that would make the app better, because there's a lot of things that could make this app better, but it wouldn't make it better for the end user, which is the developers trying to learn the Bitcoin Dev Kit. So that's the sort of the trade-off that we're trying to do here. I want you to be aware of it if you're considering opening a PR for this. And when we speak about UI, because we're not going to talk about UI and like beautiful user experiences and actually the right way to build things. Not that I want to say there's one right way, but there's certainly better ways to build things and back up the wallets, that kind of stuff. I want to share my screen and show you a very important project in the game called the Bitcoin Design Guide. The Bitcoin Design Guide is a community project. They have a Slack server you can join. There's like 1,700 people on there. So it's very active. It's firing. It's very cool because it's a deep exploration of what Bitcoin should be or could be or can be, right? From a user's perspective. Bitcoin is so software-ish. It's such a gigantic, monumental piece of software, and for so long it's been about developing that software that, you know, people speak with like jargony terms, and you've seen this if you've been in Bitcoin now for a few weeks and you're just a beginner. It's really hard to grasp all of this, and this line between who is a user of the software and who is a developer of the software is sort of been blurred for a long time. Every user was also somebody who was pretty technical. Was a lot of computer scientists were users of Bitcoin, right? But we're trying to go past that and help people that are not software developers, or not like technical people, to get them to use Bitcoin. And that is not been the approach of Bitcoin for so long, because those were the same people. The people developing it and people using it were the same guys, the same folks. So guys and girls. So, but and now we're trying to bridge that gap and jump into the other side of that wall. And there's a lot of work that needs to be done on the user experience side. And so that's one thing I want to say. The other thing I want to say, which is absolutely mind-boggling, like if once you understand this, it's just so cool. It's a quest you cannot, like a thirst you cannot quench, is that Bitcoin is emergent consensus. Nothing about Bitcoin is set in stone, decided forever, whatever, you know, like, or nobody gets to dictate what exactly is going to be. And an example of that, for example, is the symbol for the Satoshi. I think symbol for the Satoshi right now is being discussed and discovered real time on Twitter, on GitHub, on all these like Discord servers. People are sharing different ideas for the symbol, and there's just nobody to tell other people what to do. We don't have some sort of a deity we're waiting on that can tell us what to do, what to use, right? So it's like thousands of developers together at the same time who are trying different things and are just like attempting to use different symbols, and we're trying to see what sticks. And this is just one example, but there's like thousands of those. And it's all of it is emergent consensus. A lot of the words we use for Bitcoin are just, do you, should you use a seed phrase or a mnemonic or a recovery phrase, right? These are just things we're figuring out as we go, and nobody's there to say the final word on it. So the Bitcoin Design Guide is trying to take a stab at that, is to create, to help participate in that conversation of emergent consensus, to say, hey, this is our voice. We've thought about these things deeply. I mean, the folks on this Slack servers are just like, I mean, the conversations they're having about this, the most minuscule change of like, colors or like font sizes or anything. It's really, really cool. And if you know anybody who's in design, or if you're interested in design yourself, like join the Slack. It is super cool. And they have like weekly chats. And anyway, it's a really cool community. I recommend checking it out. So the Bitcoin Design Guide has a ton of opinions, and those are like being developed real time on how to design Bitcoin wallets. And this wallet is not using a lot of those recommendations because I'm trying to stay like really lean. But if you're building an Android app nowadays, you have to go through the guide. Like, I mean, that's just like the beginning of it. You need to start, at least understand where the conversation is right now at the moment, what people are thinking about, how we want to present to the users. Don't go through this journey yourself. If you've developed an app before, it's a very complex task of like thinking of use cases and how people are going to use your app. And don't go through this journey yourself on your own. Check out the Bitcoin Design Guide. It's a cool website. So I'm sharing my screen. Hopefully you're seeing my screen right now. But it's a ton of articles on, how to design and looks and, private key management. There's really cool stuff. So, and some of the words that I'm using here, for example, recovery phrase is I know that it's like the recommended basically wording from the Bitcoin Design Guide, and that's why I use it. But I think that this is an example of an emergent consensus over time. It's becoming a good way to speak of it is recovery phrase rather than your mnemonic or your 12 seed words, or but that's just one out of 20 examples. So that's one thing I want to tell you guys about. the Bitcoin Design Guide. If you're developing applications, it doesn't have to be Android apps, although there's a big focus on like mobile, but it's anything that's got to do with Bitcoin and user experiences. The Bitcoin Design Guide has thought about these issues deeply and is ongoing work. So check it out. It's very cool. Next, Android. You might have heard that Android is an open source project, and that's true. Android is developed and maintained by Google, and the open source part of it is sort of the underlying infrastructure, and it's called the AOSP, the Android Open Source Project. This should come up, the Android Open Source Project. The Android Open Source Project is gigantic and is the basis for Android. This is developed openly, and they take PRs from the community. It's a fork of, people say it's a fork. It's not really a fork, but it's sort of a, they took huge parts of the Linux kernel basically, and then created a bunch of optimizations and made it work on mobile devices. And they take PRs from community, but in general, it's not open source as in free and open source software. It's more like Google says you can look at it if you want, but you know, they don't. It's not like they will merge any PRs or anything like that. So it's very like, it's still very controlled by Google, and that's it. It's kind of like you can look but you can't touch. That's sort of the approach with the Android open source project, although it's like miles better, obviously, than what Apple is doing, for example, which is a completely closed source sort of like platform. So that's the first thing to know about Android. So it's an open source project, and then what happens is that this AOSP project is sort of a basis onto which you create your own flavors of Android. So if you buy an Android phone and it's an LG, for example, it will come with its own sort of like wrapper, you know, the look and the feel will be just a little bit LG. And if you buy a Samsung, it'll be just a bit at Samsung, whatever. This part is what the vendors provide. So each vendor, when you make a hardware, you need to provide to Android the drivers that allow the camera to work, the internet. There's like a bunch of things that need to connect to the hardware. And those are proprietary often by the hardware providers, right? So if you're Samsung, you have a bunch of drivers you don't want people to know. So these are closed source, and those are called binary blobs. These binary blobs are provided by the vendors. So the vendor, for example, Samsung will pull in the AOSP, the Android open source project version, whatever. And then on top of that, they'll add a bunch of their sort of like their layers of apps, the basics they want your Android flavor to come with. So it'd be, you know, nowadays most phones will come with Facebook, for example. And even if you try to delete it, it'll say, no, you can't delete it. So that's your vendor putting it. It's not the AOSP. The AOSP project comes with like almost nothing. It's beautiful in its simplicity. It's very lean. It doesn't have any. It doesn't have anything really of Google. It certainly doesn't have any Google in it. So there's no way for you to connect to the Google Play Store or anything like that using the AOSP. That's added on top of that another layer called Google services. These Google services you can leave out if you wanted to. You could build, if you want, you can build AOSP from source. It's a big task, but you can do it if you want, and you could fire it up on a phone if you wanted to. The main issue there is that for most phone, you don't possess the binary blobs, right? So for example, if you have again, maybe a Samsung phone or an LG or whatever other phone you use, you could build AOSP, but you don't have the binary blobs for the vendor. And so it wouldn't work for you. Like AOSP would not be able to use your camera. Would not be, I don't even know if it would be able to use your screen really. So those need to be provided by the vendor. And the way a lot of the other distros, right, because there are distributions of Android that are not Samsung or whatever, LG and all the others, they use they support hardware devices for which they possess the binary blobs. And Google has a phone, obviously the Pixel, for which it provides the binary blobs. And so if you want to build another flavor of Android, you can grab a Google Pixel. Google will give you the binary blobs for it, and you can build AOSP on it. And so that's why for a lot of distros, for like phone distros, right, if you want to download like Privacy or Lineage or these sort of like more advanced, or not advanced, but like separate versions of Android that do not have any Google in it, it's possible to build them. Like, so people build them and they're distributed and you can download them. They only support a few devices, obviously, because it only works on devices that have the binary blobs. So that's an example of how it works for AOSP. Let me just check just one thing. Okay. Any questions on this? Good. Android AOSP, then Gradle. Okay, so let's start digging into the code base. It's 10:30. That's good. We have about an hour and a half. I think we're doing good. Let's see. You folks are seeing my screen?
Yep, looks good.
Okay. I'm on the Summer of Bitcoin wallet repository. I have it open in my Android Studio, and I'm on the master branch. If you haven't worked with Android Studio before, it takes a bit of time to sort of understand that the outer edges of the screen have a lot of like functionalities, and you need to sort of explore them. But here, for example, if I click on the Git tab, I'm not even sure if it's called a tab, but you'll be able to see the branches I have. And so there's a lot of branches. I have, for example, a branch for each of the tasks we're going to accomplish today and tomorrow. And I also have tags for those. And if you're not familiar with how to do this, it's in the tutorial as well. And Android Studio provides a terminal. I'm here and I could do a git branch to see where I'm at. And I could do, the first thing would be to fetch probably all of the tags. I don't know if they come by default, they're there, but if you fetch all now, they'll be there. And I could do Git Checkout task 1, if I'm not mistaken. Yes. So now I'm on task 1, and it'll tell you that you're in detached head mode, yada, yada, yada. If you want to create a branch out of this, you can follow the instructions there. And so this is my code base right now, and I'm on task 1. I suggest you all pull this task 1. So again, it's git pull or git checkout task 1. Add simple working activity. And we're going to have a quick look at my website. Summer of Bitcoin. Prerequisite, you've all built a test app, and this is what we should be getting once we build this app. A basic Android activity. So if you haven't worked with it before, up top here are your emulators. I usually run it on a local phone, but for the video and the screen sharing, I'm going to be using an emulator, which is why I had to borrow somebody else's computer. And if I run this app on this tag, I think we should be getting the basic app, I hope. At the bottom here, you can see Gradle build running. So it's building and compiling the app. Once that's done, it'll move on to installing, and I'll install it on the emulator. See if you can build this on your local machine. It's not that you need it for the tutorial, but it's obviously it's way more fun if you can build it and see your changes as you go. And usually the first build takes quite a bit of time, or not quite a bit, but a lot of that stuff gets cached. If you, oh, there you go. Nice. So I've got my one activity. There's no button. There's nothing I can do with it really. Can go back and it just deletes it. Boom. There you go. And when I look at my code base here, the first time you look at an Android project, it's a mess. There's a lot. I remember just being like, what are all these things? And I think over time, you sort of like understand what each part is doing. But some of the important ones that you can sort of discard in your mind immediately are the .gradle directory, which are just Gradle caches. So that's your compiler tool, Gradle, and it uses caching. And so the second time you run the app, it'll be much, much faster. And so a lot of caching that doesn't get put on Git. Okay. And then the build are also, the folders are, those don't get committed to Git. So they're now part of the source code. The first thing we need to talk about when we think of Gradle, when we think of Android apps, is that the build tool for Android apps is called Gradle. And Gradle is having some problems here, but I have a link on the PDF file. And we won't have time to go into Gradle in this workshop because Gradle is really a complex tool, but it's super powerful. And it's very useful. And I think that it's worth your time if you are considering building Java applications, Kotlin applications. It works, you have here C++, even JS. It works for JS stuff. And of course, Android. And the problem with Gradle at first is that everything looks just so weird. It's not obvious what it's trying to do. I might have to restart my application. Sorry, my IDE is not sort of recognizing this file as a Gradle file. So it's giving me all sorts of errors. Hopefully it doesn't do that on your side because it wasn't for me yesterday. It might have to do with my checkout. I'm not sure. I'm just gonna try to check out master. So and Gradle has these basically these blocks. We have these files that help us define how we're going to compile our app. And there's different files for Gradle that are used at different levels of your project. Usually for an Android project, it's 2 Gradle files. So, and those Gradle files are written in a specific language called a Kotlin Dsl. Kotlin out of the box allows you to create domain-specific languages, and it's a really powerful feature of the language, this ability to create DSLs. And if you're not familiar with DSLs, they're sort of like a way to create mini languages for specific tasks. So if you have a very, very specific task that you do all the time and you'd like a way to configure it or to create it and to build it very custom, these DSLs are basically what they do. And so Gradle has created this DSL just for itself called the Kotlin Dsl. And that's what we're doing here. We're using this sort of mini language for it. And it looks almost declarative, right? We have these blocks, and these are just lambdas. And that's why the IDE, because it's pure Kotlin, there's nothing about this that's not Kotlin, but it doesn't look like Kotlin. And so the IDE recognizes, you know, the receiver here. We're seeing that this script handler scope and then repository handler. So you're providing arguments to these functions in the forms of lambdas. So the important part here is that for the all project block starting on line 12, you're giving Gradle direction as to where to go to find the dependencies you're going to need. And it's going to go to get those dependencies in order. So if it can't find it in Google, it'll try Google first. If it can't find it, it'll try Maven Central. If it can't find it, it'll try JCenter. And if it can't, it'll use Maven Local. And because you've built the test app, you're familiar with your Maven Local repository. We're just going to go have a look here. Right, so there's this repository, cd repository, and then this .m2 is the repository, and in there is Maven Local. So when you ask Maven Local for libraries, if you put anything in there, it'll sort of like scan that, and you can use them if you want. So this is why we have the org, and then Bitcoin dev kit, and then, you know, if you print the whole directory for this, you're pretty deep, but the Bitcoin dev kit is there basically, right? You've seen what you downloaded. I'm just going to have a quick look there. JNI, and then CD. I think we're in. So this is where we're at. And now I have multiple versions of that library. 0.3, say. Is that going to work? No. Sorry. And so you'll find that in this here, we have an R file, the AAR file here. That's the actual library. So that's what Android is going to pull, and we'll end up using it. And the location of that declaration is here. If you look under the dependencies block, you'll find the Bitcoin dev kit, which is our task 5, and that's where my dependency is declared. Dependency notation, blah, blah, blah. So note that, again, we talked about Android framework versus libraries. The Bitcoin dev kit is a library, and I'm pulling on it here. I'm pulling it into my project here. This 0.3.0 release candidate 1. So, and the rest of this build.gradle.kts is under the app directory, right? And that's where the bulk of the application and the configuration is all defined. You know, there's a bunch of stuff in there, and that's what we use for defining Android apps and telling how did you compile these? Sorry. So we're defining those there, and when we tell Android Studio to build our app, it'll run these Gradle configuration files. And when you look at Gradle is a compiler tool. One of the problems you're going to have is that there's different versions of Gradle, right? So the first step in there is to ensure that everybody uses the same version of the compiler tool if you want to end up with the same app. And so all apps, or most apps, usually if they're well built, will come with their very own binaries for Gradle. And that's in the Gradle directory here. If you look in the Gradle directory, you'll have a wrapper and the jar file. And if you look at the wrapper properties, you'll find that right now, for example, I'm using this 7.1.1 all zip, and that makes it, and that's committed to the GitHub repository, right? So when you clone the repo, it'll give you this property file, and your Android Studio will start downloading immediately the right version of the Gradle I mean, and then you have a wrapper, and that when you run Gradle tasks on your command line or on Android Studio, it uses that particular version of Gradle. So different projects will run different versions of Gradle, and that's how we ensure consistency between builds. So at the bottom there, hopefully it's not too small. I'm not sure. I'm hoping my the font is not too small. I don't know if I can bump it up. Nope. I could do, for example, I'm going to run this. It's too bad this command line that I have right now is not really showing me colorized output, but the Gradle W is the wrapper, is the script that will allow you to use the Gradle jar file and to use it consistently. And so we call this Gradle W, and then we give it commands, we give it tasks. So one thing we do with Gradle, for example, is to say, well, this Gradle W, I want to use it, and then you give it a command. So I'm going to give it the tasks command. And you see that it outputs a bunch of tasks. And these are all accessible from Gradle. So when you say to Android Studio, hey, run this app, what it does is it runs a tree of tasks from Gradle. And so those will include maybe running your tests, and then, compiling your dependencies, and then, then checking for other things, and and then eventually building your app, and eventually installing it on your phone, maybe. And so that's how you end up with a working application working on your phone. So it goes through these tasks, and you can run any task like individually if you want by running these things. And that's sort of the idea behind Gradle. I don't want to spend too much time on Gradle, but that's how we're going to use it. And the UI way to use this is, I'll show you because you don't have to use the command line for this. You go top right here. You should see a Gradle tab, and if you click on this, you'll find that you have a bunch of. Well, right now it's not. For me, it's not like finding this as a. We're still having problem with the IDE not finding it. So, but for you, when you go under app, you'll find a bunch of tasks, like the equivalent of what I have here in like green, you'll find there under like these little drop-down menus. And from there, you could like double click on a task, for example, run tests, and it'll actually run you tests. So that's the UI way to run Gradle tasks. So we have one question in the chat that I want to address. And it is, how did you compile these like from Rust to these .pom files? So that's super cool and a very good question. And we're going to go and have a look. So in this Bitcoin dev kit, right? When you're on the Bitcoin dev kit organization, you can go down and look at the BDK JNI. So the Java native interface, which are the language bindings, again, that will allow us to work on Android. And this has a README on how to build the library for yourself from source. And the first part of that is to indeed build it on the Rust side. So you want to build the whole Rust binaries. And without going into too much detail, the way this works is we use the library on the Rust side, we compile all of this, and we compile it for all of the target architectures. So there's, I think for mobile devices, there's 4 target architectures. And most phones are this particular one here. ARM v7. No, actually, sorry. I'll check. But anyway, you're going to compile the Rust binaries for all those four target architectures. And then you're going to run. See, notice that here, what we're doing is using, again, the Gradle wrapper and calling a task on Gradle. And this task is called build. And that task is defined in the build.gradle direct files here on this BDK-JNI library. And when it builds, it will build the whole library plus the files that are necessary to access it from an Android perspective. And that includes all of the Kotlin objects, that kind of stuff. And once you have that, the last piece you're going to do, so at that point you have the full library, but it's in your repository of BDK-JNI, so you've built it locally for yourself. And if you want to put it into your Maven local, which is a very common task, everybody usually, once you've built it, you want it accessible in your Maven local repository, you can run this other task here, Gradle W, publish to Maven local. And that's super simple. It just like puts it, it just basically sends it into your location the way we had you guys do it. The problem with this was that initially, the reason why you guys haven't built this from scratch was that we didn't want you to run into troubles with the Rust toolchain and not being able to compile and having other problems. So what we did is I built it locally and I shared it on the Google Drive, and that's why you have access to it right now. So you just downloaded it, but it's the same aspect. And if you're interested in Android and using the Bitcoin Dev Kit, this is definitely a task you need to sort of like get familiar with and make sure that you can run this locally, because BDK-JNI is like, you're going to want to build the new ones as they come out. The Bitcoin Dev Kit for Android right now, BDK-JNI, is not available publicly. So it's not like it's on some sort of server that you can just like declare it as a dependency and it'll download it. It's not there. And that's because of what I talked about a bit earlier, where the Bitcoin Dev Kit is actually going to migrate to a different language binding approach to match up with the Lightning Dev Kit project. Once that's done, we're going to publish up to Maven Central, and so you won't have that problem. You'll be able to just use it as a dependency, just like any other dependency. Did that answer your question? Building it, the build task of this line is the one that'll create the POML files and all of the stuff that you need. So when Android says, hey, I want to use this dependency, it needs a lot of metadata. It's not just an R file or a jar file, right? It needs metadata as to where to go and how to find that kind of stuff. So that stuff. And so to give you an idea, it's important to understand the language bindings. What we do is we create the binaries for it, right, that are targeting the architecture. So that runs, it's not on the JVM, it's not on the ART, the Android runtime. It's really binaries that run on the machine, on your phone. And they connect with Java right now through C, what's the name for it? Not the C interface, but like C objects. So because all languages sort of like share this understanding of how C objects are built, what we do is we can connect Rust binaries, and we give them sort of a window to these C, I'm forgetting the word, but this sort of like this ability to connect with a C structure. And so from the point of view of Kotlin, or from the point of view of Java, what you're interacting with is actually just a C object, or you think it's a C object. It's not. In the background, in the backend, it was actually compiled using Rust. But from your perspective, that's the API you're using to connect with. And I want to take the time to go through these two files. This is BDK-JNI, and it has two files on the Kotlin side. So it's super cool. You can go into library and notice that it has a build.gradle file. So again, it's the same thing where there's a bunch of tasks and dependencies, and it publishes to local Maven, right? See, notice that it's in there. So that's that task. And if you go into the source main BDK-JNI, it has two files. Super simple, neat, right? Again, we're not developing any other functionality that are related to Bitcoin outside of the Bitcoin Dev Kit. It's just about wrapping this functionality into these types that we can use. And so I really recommend going through these files. They're not long, like this is like 80 lines. Even if you don't understand like the whole of like the other file, that's the more complicated one, understanding the data, the types that are provided to you is really, really useful. So when you're using the Bitcoin Dev Kit on Android, or soon, hopefully, because I'm working on that PR, soon you'll be able to use the Bitcoin Dev Kit on the JVM as well. So if you want to build desktop application or server-side applications, which is one of the projects I'm working on, you need to understand what are the objects that are available to you and what are the types, like what's being returned, right? And so it's these super simple things, data classes. A lot of them are data classes. You know, TX out, UTXO, and they have like an out point, you know, they're neat. And from those, you can then, if you know their types, you can then parse them and use them. And yeah, so for example, the create TX response type is a data class that has a details value, which itself is transaction details. So, and that's that type here, up here. So does that answer your questions? Here for this, there's the type, and then there's the lib, which here, the cool part of this is line number 23, where it actually loads the library. So you have this library that's in native code, and you're just loading it. So you say, hey, bring this into memory, and from there, we're going to speak to it using sort of like you know, there's the JSON RPC there, and it basically uses sort of format that both sides will understand to share data back and forth. That's how it works. Steve is telling me that I should double check my project setting JDK. It could be why Android Studio is having a problem with your Gradle sync.
Yeah, that's where I was thinking to check it. And other folks might run into this problem too, so it's probably not a bad thing to check. So if you go to the hit project, SDK, the SDK location. So this JDK that it's mentioning, where is that? Yeah, I know I've just had problems before with this if it's pointing to a JVM and not a full JDK. I don't know if that's the problem you're having or not. But anyway, yeah, you can, if you maybe afterwards we can straighten out. But
I've had this problem a lot before. I solved it on a few different machines, but in the end, actually, it's not. It's a problem for the IDE, but it's not a problem for building it. So, for example, we can fire up the app here, and I would think it'll build. And now we're building master, so this should show us the final app. Yeah. Hopefully you've seen this by now if you've looked at the tutorial. So I'm using a color theme called Nord. It's a famous theme. I just was looking for something that worked. And this is sort of where we're going. You can recover your wallet using your 12 words. And if you try to recover with something, wrong, tell you that, and you can create a new wallet. Oh, okay. So what's happening here is that we can look at the logcat, but it wasn't finding the Bitcoin Dev Kit. Okay, we'll fix that later. So I'm going to check out task 1. Those are most of the files I wanted to talk about for task 1. No, sorry, there's a bit more. Task 1, right? Again, we're just building, and I'm going to try to rebuild it. UI is slick. Nice. Thank you. Sync now. so we have these build Gradle files, and then if you go into the source code directory, you'll find the main. Yeah, we're gonna do that. I think that some of the issues we're having is that I've upgraded the Gradle plugin as I went. So when I pull on master, I'm on the latest version of Gradle, the Gradle plugin, at least for the IDE. And when I go back into the previous tag, we're looking at like an older version. And so it's just sort of like having a hard time here. This is the problem here, the 4.2.2, which is now being upgraded, but I should be able to resync Gradle. Yeah. Anyway, so when I'm in the source code repository here, I'm under main, and I should find let's just see if this this app will fire up. This should be our basic activity. Hello world. Nice. So you'll see that it has nothing, and it's only one activity, and it has one screen. So again, to speak really quickly about activities, Android thinks of they don't have to be screens, but like the big pillars of your application are called activities. So an activity can contain many screens, and it's sort of like a one piece of related screens, right? So they have a common functionality, and they have a common purpose. Activities are heavier than fragments. So within an activity, you have a bunch of fragments. So these are the screens that you navigate between. And so the fragments are much more lightweight. They don't cost as much to create or to destroy, basically. And so even from, if you look at nowadays, like Google's recommended way to build apps, a lot of apps will be actually single activity apps. That's their name. We call them single activity apps, where like the whole app might be just one activity with multiple screens, multiple fragments. But here we're doing one activity, and it has no fragments. It's just that activity. And the code base is really simple. I have two big folders that are important for us and one file. So the Android manifest file is sort of like the one file that your phone will read initially. Like when it fires up, it reads this manifest, and it has a bunch of metadata about, what's your theme and what activity to launch first, because you might have 3-4 activities, right? Our final app has 3 activities. We'll talk about it later, but for now, it has only one, but it needs to know which activity to fire up first. And that's what's described in my line number 14. Yes. So we're saying this is the main activity, and fire it up when you start the app. I want you to fire up this activity. This is the manifest. The manifest is also the place where you're going to say, hey, this app requires access to the camera. This app requires access to your contacts or whatever. This is defined in this manifest. And the manifest and the application is able to ask the user, hey, do you want to grant permission for the camera, for example, or do you want to grant permission to see your contacts? That's the kind of thing. Then the other two important directories are the Java one with the package name and then the main activity file. I wonder if this is going to read well. Okay, yeah. Look at how neat this is. This is like, and this app will work on like 5,000 different hardware phones. And this is it, 11 lines, right? I'm importing 2 dependencies, gosh, 2 things, I guess. And here I'm starting this main activity. And we talked about how we need to we're playing on Android's turf, right? And so here in this case, when you want to create an activity, what you do is you extend a class that they provide, that Android provides, and that class is called app compat activity. So I'm extending that class and into a class that I call main activity. And then it has a bunch of methods that I can override. And this onCreate is one of the basic ones. When Android will fire up your activity, it'll fire up the onCreate method on that class. And for me, I want to start the onCreate of the parent, so the app.compat activity, and then I want to add some of my own versions of things I need, right? And the one thing we do here is really the meat of this whole file is line number 9, where I set the content view to be this particular layout. And this file, this line, is you want to spend time making sure you understand what's happening here. When you give it a set content view, it requires, it'll say, what I need is to give me well, you have different way to construct it, but one of them is to provide a layout file. And this layout file is under your resources file. So that's the other big folder here on the left, resources and then layouts. So these resource folders are generated automatically for us, and we can create other ones, but they become sort of like, you know, the saying, it's like convention over configuration, where by convention, Android will go into these folders to find what it needs. So these are like resources that are very static. If you think of web development, right? A lot of it's kind of like the skeletons or the CSS, that kind of stuff. It's really static. There's no, you're just like defining them and then it can pull on it. And the Kotlin code is the part of it that's kind of like the equivalent of the JS, where we add the functionality to our apps. So what I'm seeing here when I look at the resources is a bunch of stuff, and what we care about is the layout folder. And if you look at that, there's only one activity in it, one resource, and this is it. I'm just gonna scroll this so you can see. And if you haven't worked with Android Studio before, what is cool about it is it offers you the ability to see your application either in code version or code and visual, or just sort of like the visual version. So that's what we're doing here. By default, I was on the design panel, but if I go into code, you'll find that this activity main XML is just a bunch of XML, and XML is very similar to, if you're familiar with HTML, it's very similar to that. We're providing sort of the bones, and the XML, the layout files for Android are similar to an HTML with the CSS inside of it almost. So you have these tags for things we care about. So this is, for example, a text view. I'm adding a view. So these views are anything that's like a button, an image, text. They're called views in Android. And we draw them on the screen using these XML tags. So here I'm drawing a text view on the screen, and to this text view, we can sort of customize it by adding a bunch of stuff to it. So here I'm defining the text on it, right? Line number 12. There's a height, width, constraints. So we're playing within a big XML tag that's called Constraint Layout. And Constraint Layout is one of the most popular layouts in Android because it allows you to define how you want to constrain your app. So if I click on it, and I recommend that when you start playing with it, you start with you play around with the Design tab, and the Design tab will allow you to look at your views and click on them and see, you know, stuff that's happening. So here I'm looking at the Constraint Layout, and I'm just going to move this on the right hand side here. I'm seeing a bunch of those attributes that are, you know, see how it says hello world. I could remove the, there you go, and then the view gets rebuilt in the UI. And right now I have like 0, but I could put it to something, or I could delete this, for example. Oh, and it would like drag all the way to the bottom. And now if I'm looking at the code, my code has actually changed. So this is how you develop UI in Android right now. That's one of the ways. There's a new way as well that we'll talk about a little bit tomorrow, but this is the good old way, is using XML files. And what I'm going to do, for example, here is to take this and add a constraint to say, hey, I want it, you know, to pull on the top as well. And you notice that it added this to the code. And now this view is right smack in the middle. Just want to check the chat. Does that make sense? We can't go over all the CSS, not the CSS, sorry, but the attributes. And there's a lot, and you'll see the layout files. They get bigger and bigger, and it's a hard thing to parse initially. The UI is really important to sort of have a look and see, and you can even use it to add views. So for example, if I take a button here, I can add actually a button there, and I can like move it, you know, and like put a constraint and just drag it there. And now if you look at the code, this button has been added. So I recommend you play, it's a mix of code, because the code is so much more explicit, right? Is cleaner to parse if you need to. But if you want sort of a visual aid, definitely the design tab is the way to go. So I'm going to delete this button, and we're back to where we were. Making sense? This is our main activity. So we've talked about the three big files at this point. It's the Android manifest, the layout file, and how those layouts get constructed, and then our main activity. And if I try to run this app, it'll say, whoa, this is not working. The set content view, you haven't set any content view. And I need to provide Android with the right layout file. And the way we do that is we access this file using system that works the following way: r.layout. R stands for resources. And so this R is provided in any of your Android classes like main activity. This app compat activity is, you know, main activity is extending this class of app compat. And so it comes with the R defined here because it's Android. So I say R, and it says, oh, I know what you mean. You mean the resources. And I say, yep. And my next part is I'm looking for layouts. And I said, okay. And then dot. And you have different layouts that I can use, right? And I'm going to use activity main. Now it knows to go into my layout and pick this particular one. And if I fire this app, we should see that it works. Questions on this? Cool. Task 2, activities and fragments. Let's have a look at the. Let's have a look at this. All right. Our second task is to build multiple activities and navigate between them. So when we create activities, then we're going to use this thing called intent. Intents are for navigating between activities. So, and certain activities in Android don't have to be necessarily screened. So some of them can be like background services, for example. So you could fire up an intent for a background service. That's possible. Or there are some cases, for example, where, for example, if you require a photo, right? You want to share, pull a photo. You want to take a photo from your app. So you're going to need the camera, right? But Android doesn't let your app take control of the camera itself. So what you do is you make sort of a request to the operating system and say, I'm making a request for the camera, and this is my intent. What I want is I want to get back a photo. And you can define other options, and then the OS will say, okay, sure. And it'll fire up your camera, and then you'll be able to take a photo. And when that photo is taken, it'll return back to your app with that photo, and then you can decide what to do with it. So that's sort of like the way the operating system ensures that your app doesn't go and play with hardware, or doesn't go to play outside of its available and its own sort of like sandbox, right? You want to make sure that all apps are sort of stuck in their own little prisons, so they don't get to touch other apps or know what's happening outside of themselves. Often that's a security feature that's provided by Android. Oh, sorry, not tasks 3. So let's pull task 2. I didn't know that I made changes. Okay. I'm just going to roll back all of that. We don't need this. Okay. Add a simple working activity. Create 3 activities. So now if we look into our code base, let me know if you guys are getting there. If you guys are all there. Again, notice that my 4.2.0 beta, that's the problem, yeah. But somehow it doesn't read the rest of it. It messes up the rest of it. If you don't mind, I'm just gonna close this and see if I can resync or sync project with Gradle file. We're gonna try that first. Nope. It is synced, but it's still not recognizing the build script. Doesn't matter, we'll fix that later on today. Tomorrow it'll work out. Okay, if you look at your source files now, you're gonna find three files, right? I have my wallet activity, which is my good old activity that I had. And now I have a dispatch activity and a wallet choice activity. And what those are doing is our idea first here is to create a single activity that will be a dispatcher. We want to say when the app starts, we want to take a look at whether the user already has a wallet on device. And if it does, you want to go right into the wallet, like show the user the wallet. And if it doesn't have a wallet, then you want to say, well, you're going to need to create one. So you're going to go into a different part of the app. And those are the 2 activities. So in total, we have the dispatch activity, and then we have the wallet activity and the wallet choice activity. So those are going to be the 3-1. And the wallet, when it gets going, if you look at the Android manifest now, you're going to see that I have 3 activities now, right? These are all activities. I have my dispatch activity, my wallet choice activity, and my wallet activity. And you're finding that line 16 here shows you that the main activity, the one that starts when you fire up the app, is the dispatch activity. And so this dispatch activity is really interesting at this point of the game. And this is what it is. And I've actually commented out the code that would give you that fork, because for this at this version, we're just the dispatch activity starts and it immediately fires up into the wallet choice. I don't want to send people into the wallet, and we haven't created a way for the wallet to check, for the application to check if the wallet has been implemented before already. So we have no way to know. And so we always go into this wallet choice activity. I'm going to try to fire this up and see if it works. And line 21 is the line that matters here. Notice that it starts an activity. So my dispatch activity on create, again, we're overriding this function on create, this method on create. And when it gets going, it immediately starts a different activity with an intent. And that's how you start an activity, is you give it an intent and you say, I want to, fire up the wallet choice activity. And then I finish this dispatch activity. And this is what happens when I fire it up. The dispatch sends me immediately into this wallet choice activity, and I can say, boom, That's when I press the button. I'm right there. Wallet choice, and wallet choice is what we had there with the button. This is the wallet choice activity. Note that we're using a technique that's a bit more recent in Android history, where a lot of the elements that are declared in our layout, right? If you look at this, we're going to find that there's a text view and a button, and both of those have an ID. You generate these IDs by using this little syntax here, the @+ID, which it creates a new ID for Android, and it knows about it. It's indexed. It understands what you mean by that. And each ID, in this case, both of those tags, has received, each tag, sorry, has received an ID. And that means that they are now accessible through what is called view bindings. And view bindings, I'm declaring this here. I'm saying, please inflate the bindings for the activity wallet choice binding. And it's important, it's imported here on line number 6. And that exists, it's just generated automatically by Android. It's part of the Gradle file. I've declared that I want to use view bindings. All modern apps do. And once I do that, all my files in my layout files get automatically generated into these objects called, for example, here, my layout file is called activity wallet choice. And so I have a activity wallet choice binding object that's created. That's built by Android. I don't need to do anything. It just appears. And so I can import it immediately and create a value, right? If you're not familiar with Kotlin, value is sort of a variable that you can't change. It's a read-only variable. And so I call it binding. It's very customary to call it binding. And that's what we did. That's what we do here. And so once I have that binding, I can do binding dot and then access any item in my XML file. Just going to close this. So notice that I have a button and its ID is thank you button. And what I'm doing here is I'm saying binding dot thank you button. So I'm accessing that button and I'm on that, and on that button, I will create an on-click listener. And that's sort of like, to that on-click listener, we're passing a lambda. So we're saying, whenever you get clicked, this is what I want you to run. And what I'm doing here is creating an intent and starting an activity with that intent and then finishing the activity. Pretty sweet. So this binding is created, this set on-click listener is created immediately once the activity is created. As the activity is created, do you see, like, where I'm overriding the onCreate function, the onCreate method, and that's why it's happening like immediately as the activity is being created. So this button now has a binding on it that will run these 3 lines of code whenever we press it, and indeed that's what happens here. It fires up the new activity. I'm going to tell you about logcat here at the bottom. We're going to be using logs a lot, and that's where you find the logs for your wallets. So you should explore some of that, how that happens. But when you press buttons and you go back and do things, it'll show up. It'll show up in your logs. Sorry, this one's not working right now. But does that make sense? I feel like that was a lot. Again, there's a lot of that's very Android specific. Working with the UI, working with the code, that's good. We've talked about this. It's very Android specific. So I want to take the time you need to explain it so you understand what I'm doing. But it's super normal if you're feeling a bit overwhelmed and like this is a lot, and the supers and the, you're extending weird classes, intents. all of that is provided by the Android framework. And so you're just playing the game of you're playing the Android game, basically, which gives you superpowers, right? All of that is really cool and works on all devices, different memory systems, different, memory hardware, like some of them will have almost no memory, some of them will have a lot, powerful, not powerful hardware, different types of screens, all of that. That's what the Android frameworks allows you to do, is to use these APIs to basically work on everybody's phone. So, but you need to learn how they work. I'll check the chat here. How's everyone feeling? Are you able to build, are some of you at least able to build the task 1 and task 2? Tomorrow we'll, or we might even do that. Okay, cool. We might even do that today, but I'll have you sort of like add screens, or add maybe not screens at first, but views, and creating new buttons, and seeing if you can create some of that stuff. But yeah. Oh, I like that, the yes, all caps. Somebody's just very happy they're able to build it. Scream it out loud. So yeah. Maybe another thing I want to mention is part of those resources for Android. Another important folder is the drawable folder. We don't have anything in there right now. Yeah, the launcher. Okay, so whatever. That's the icon for the app. But a lot of the logos, the SVGs, the images will go into this drawable folder. So that's where you'll find them. And another one that's important is the values folder. So values provide you with, there you go, examples like strings. The themes are in there as well. Colors. So this is the kind of thing you can define a lot of these items there, and then afterwards you can refer to them by name. So much easier, like when you're building layout files, you don't want to say, hey, this button is this particular hex, like that's the color. It's too hard to maintain. Rather, you want to just name, I want this button to be blue 700, and that blue 700 is being pulled out of the values that are defined in this color directory. Okay, sounds good. Thank you, Eddie. Any questions on this? Okay, good. So we have a lot of resources. We can use them for all sorts of stuff. And we need to be able to navigate between the Kotlin files and the resources files. And those are yeah, how we usually define a lot of the UI. So that's sort of what I have for task 2. I think we're on task 2. Are we on task 2? Yes. Task 2, manifest. Yep, navigating. Okay. Task number 3. Task number 3 is like, this is where it starts to get interesting. We have these 3 activities, but I want to be able to navigate within the wallet activity. Now that's my big activity. That's where the meat of the app is. And I want to be able to navigate between different screens. And those screens are going to be called fragments. And the general idea there, I want you to think of it as, let me just pull it out, sorry. Actually, is this gonna, might have to roll back all of that. Git checkout task 3. And hopefully this provides you with a sort of a blueprint to create your own, right? You should feel free to fork that code. This is Apache 2.0. Fork that code, and then start from, or use it as a template. Maybe start from scratch and like use the code that's in it to see if you can create the navigation and the things, or you can try to fork it and just from there build something that works. You'll see on task number 4 where we really dig into the color scheme and like we create the UI. From there, like I'll show you a bunch of stuff, but like the way I did task number 4 is I initially just created wireframes. And I mean, this is what I built maybe like 2 or 3 weeks ago before I built the app. And to give you an idea, and this was, this was my first line. And a friend of mine was like, "That's disgusting. You're not doing that. That's disgusting." I was like, "Okay." And so from there, I started like a light theme. And if you haven't played with Figma before, it's a really powerful tool, and it's a good way to sort of play around and develop user interfaces. So it allows you to not write any Android code and just play around and create color schemes. So that's kind of how I developed this. These are the latest versions. This is what we have right now is the Nord theme. But you should feel free tomorrow to fix it up, try a different color scheme, find something different. These are, I typed in, I think I did like, retro color palette, whatever. And then boom. A lot of websites will provide color palettes for you. And you can, from there, you can like find the hex codes and go from there. There you go, website like this. Color palettes, and I invite you to try to fix it up tomorrow and see if you can come up with your own version of the app. Rename it with your name or something. Make sense? Again, feel free to stop me anytime. We're bouncing between a lot of ideas right now, but yep. So I'm on task number 3. And the bulk of what's happening is that now, if you look in my Java directory, I have a lot of fragments. So I used to have just, dispatch activity and wallet activity. But now we have more. See, yeah. Now we have more, a lot of fragments. And the way, without going into too much detail for the way this works, is that when you get onto this activity, you're going to find that my activity wallet, for example, if you look at the UI, this is what it looks like. But it's, if you look at the code, that's not at all what it looks like. The code says, I have a toolbar. There's 2 items on this whole screen, on this activity. There's a toolbar and a fragment here. And this fragment is a navigation fragment, a nav host fragment. And it's this size. If you look at the blue, the outline here, this is what's happening. It's this fragment. And this fragment is saying, I'm a navigator, basically. I'm going to go between different places. So the toolbar is always there, right? It's outside of that navigation fragment. So it's just, you draw it on the screen once, and then the fragments are what's below. And this nav host wallet is what's called a navigation fragment. And we use it to navigate between different fragments. So that's all it is. It's just one thing. And inside, I define my navigation graph. Look at my line number 31 there. I define my navigation graph. So you're going to need to tell Android, like, who navigates where, what are the fragments, where do they go, how do you navigate between them? And that's defined in a new folder we have in our resources called navigation. If you look at your Nav Wallet, hopefully you're following along with two screens, because I don't know how you could be, if you're trying to follow on your screen and then my screen at the same time. I hope I'm not going too fast. Let me know if I'm going too fast, because I feel like I'm firing it, but if you're trying to get it to work on your screen, it's possible that I'm going just a bit too fast. This Nav Wallet Navigation is code that defines how you're going to navigate between fragments. It looks big, but actually turns out it's pretty simple. And not only is it pretty simple, but Android Studio provides sort of like a user interface for seeing it live. So if you look at the, for example, at the wallet fragment, you'll find that it has arrows to navigate between different things, and I can like move those, right? Say I move here. This arrow defines a navigation from my wallet to my receive fragment. And then the receive fragment has an arrow from it back to the wallet fragment. And if you look at my code for this, it exists right here. So you'll find that, for example, this is an action. And that's literally the arrow is defined by that action there, that action tag. It's the action wallet fragment to transaction fragment. So that's this navigation going one to the other. And then inside my transaction fragments here, notice like this is a whole fragment. I have another action, which is my transaction fragments back to my wallet fragment. So that's how we define this sort of idea of navigating between them. And when you look at the transactions at the fragments, whatever, sorry, we define on these bindings. Notice the binding.transaction to wallet button. On that button, I'm defining a navigation, and what I'm doing is line 35. That's where the juice is. I'm speaking to my Nav Controller, which sort of is the unit, the object that controls all of that navigation. And I say, I want to navigate to, and then I give it a resource ID of this particular action. So again, it's like r.id dot, and then I give it the name of an action. And that action is defined in the Nav wallet. So action transactions fragment to wallet fragment. If you look at the Nav wallet, you're going to find it in there. It's right here. And when I do that, I have an enter animation and an exit animation. So that's how those arrive, basically. And if we're going to stop the app and we're going to fire it up, you're going to see that we've added some animations between them. And the animations are defined in the anim folder. This is a new folder, wasn't there before. And they're really, really simple. They're basically like CSS. If you've built like CSS animations, it's very similar. Look at the fade in. 6 lines. I'm saying, again, it's an XML, and I'm saying, from alpha is the transparency, basically, from 0 to 1, and do it in 400 milliseconds. That's it. That's the fade in. And then the fade out is probably the opposite. No, from 1 to 0 in 200 milliseconds. So that's it. And then some of those are a bit more complicated, where you say slide from this location to this location in this time, or slide this location. And you can get really beautiful, complex ones. A lot of people have built them online. You'll be able to find like cool animations online that you can just like copy paste and then bring them in. And once you have them, you can just reference them. So in my Nav wallet, again, notice that all of my actions have an animation. And in this here, what you're seeing is that I'm calling this animation through the at syntax. So I'm saying at anim, which says to Android, like, go into my animation resources. And then this is the one I want, is the slide out left in this particular case. And now we've added a Summer of Bitcoin icon, and that's going to be in my drawables folder. Look at the icon here. summer.png. There you go. That's how it worked. And so now when I click on the thank you, I'm in this new activity that has a bunch of fragments in it. So the transactions fragment, the send fragment, the receive fragment, and the recovery phrase fragment, and then the about fragment. So these are all the fragments we're going to use for the app for that activity. So I've only created one Nav Wallet, one navigation graph, sorry, and we have one nav host fragment, which is the size of this whole screen. What's in white is the nav host wallet. So it hosts the whole like skeleton for the navigation, and then within that it just shifts the fragments. How's that going? How are we doing here? And I mean, I'm not like right now, we don't have a lot of time, so I'm not like letting you code all of this, which let me know if you want that for tomorrow. I can try to go a bit over all of that a bit quicker and let you, give you half an hour to try to build it yourself. I just wasn't sure if that was going to be the best way to do it. And I thought maybe, we'd have like 30 people with each their own little bugs, so it's harder to fix them. But I'm flexible. We have about 15 minutes left for today. I'll be staying longer if you have questions. So we'll be able to, chit chat and shoot the shit on other stuff if you have questions after this. But for tomorrow, let me know if you'd like more time to code this yourself, because right now I'm just sort of showing you my code. But what I invite you to do is basically branch out some of these, right? Take the branch and then commit on top of it. Like try to build different color schemes, add buttons, change anything you want, and you'll run into errors, and that'll tell you where you need to learn, basically. The Google documentation for Android is very thorough, but very, very big. It's a huge project, so it's hard to go through it first. And the other hard part about Android is that you're on a Stack Overflow all the time, and it has changed so much. I would say be really careful with Stack Overflow, because you'll find what you need, but you need to be able to know, and you almost need to understand the history of Android a little bit, or you develop that understanding of history over time after searching through enough answers. But you'll find a lot of answers that you might try and it works, but then the IDE will say, oh, that's deprecated. Like we haven't used this in years. There's a bunch of errors like that. There's a bunch of stuff that will not work anymore. So yeah, Android has changed a lot since 2009. I think 2009, I think, was the first Android version. So like, yeah, there's a lot of Stack Overflow answers that are completely outdated by now. So always check the dates on the Stack Overflow answers. So you can have a look at the fragments. They're very, very simple. We're overriding two functions, on create view and on view created. When we create the view, we return this binding. So we want to return for the fragment. Notice that I'm not extending the activity here. I'm extending the fragment class. It's different. And on this on create view, I need to on create view needs to return a view, and that's the binding.root. So we're returning that. Now it has a view. This view is usable elsewhere. You can see it, line 21 calls it. So I'm using my view here, and that's the same view that's being generated by the onCreateView method. And from there, I'm creating a Nav Controller, and then I add control buttons, navigation basically calls to my buttons. So you'll find that in the about fragment. They're all very similar. Receive, recovery phrase, they're all the same. They have a button that says, please go back to the main wallet fragment. How's that? Good. Okay. So that was our task 3. And then task 4, I think I'm gonna, so navigation, yeah. So you can read more. Some of the tutorial blog post is gives you a bit more maybe than what I've talked about, but should give you an idea. And then task number 4 is to actually build our target UI, and that's a super fun part if you like building UIs. But Android currently uses these XML files, and that's certainly not the way it will be moving forward. So we've been doing this for a long time, and it's this sort of HTML, CSS, JavaScript way of building things. That's the same, from the same school of thought, really, for these XML files. So you defined these sort of like static things that are just there, and then with code in Kotlin, you sort of go and ping and you change them. So you update a color, or that's a style of code that's called imperative. And in the past probably like 5 years, 6 years since React JS came out, the way we build UIs has changed a lot. And Android is a bit late to this game. I think they wanted to take the time to do it right, but they have come out, they released the library to build the newer way to build UIs using this declarative programming paradigm. And the library to do that is called Jetpack Compose. So it's built by Google, and it sort of brings Android into the modern world of building UIs. The way we do it for iOS, for example, is using Swift, and I don't remember the name for their UI framework, but it's using declarative. The declarative paradigm as well. So they've been on that for a while, and the React, Vue.js, those. So that's like the newer way, where, for example, in a year, 2 years, 3 years, you're probably going to see way more apps build where the UI is not defined in XML files, but is defined in Kotlin code. The same way we build UI now for the web that is written in JavaScript. We don't write the HTML as much anymore, right? If you use React, it's built 100% in JS. So that's sort of what it is. And the idea behind this, if you're not familiar with declarative programming, is you want to define user interface elements that are simply functions, and they build they're pure functions. So they don't have any outside effects. They only rebuild the same exact thing depending on their inputs. So a button might be a function called button, and you give it an input of the text you want on that button and maybe the color of that button. So that's an input. And as long as those two inputs are the same, the function will always generate the same button. And whenever your data changes, right, if like the user has done something and you want to change the words or the text on that button, what you do is the framework will simply say, oh, this data has changed. I'm going to rebuild, I'm going to refire that function with this new input. And because of that, you're never actually going into the things and changing them manually. What you're doing is rebuilding from scratch. There's no memory. These systems don't have memory. It doesn't know what previous button was or whatever. It simply builds based on the new data. And the naive way to approach this, if you're not familiar with this, would be to actually rebuild the whole app. So whenever you rebuild the whole UI, so whenever some piece of data changes, let's say we receive a new transaction in Bitcoin, you could rebuild the whole app, like call every UI function. There might be 70, and then you call them all and you rebuild the app. That tends to use a lot of resources to do that. And so the more modern ways to do it, for example, if you look at React, it creates a virtual DOM where it actually will check when the data changes. It'll check what piece of data have changed compared to the last time it built. and then it goes down the tree and knows which pieces of data have a requirement to be rebuilt, and it'll call the functions on these UI elements, but only those. And so that's the new Jetpack Compose. I want to talk about it because it's really the way of the future for Android. So we're using XML, but if you're trying to build real Android applications, more and more understanding Jetpack Compose is going to be important, and it's a by far a better way to build UI. So again, what we're doing is you have inputs, you have data, and whenever those input changes for whatever reason, the UI simply knows which parts of the app are affected by that change in data, and it'll just rebuild those functions. And those functions are called composable functions, and that's what it is. You have a bunch of like Kotlin functions, and once those are defined, then they can be used everywhere. So they're like reusable elements. If you've programmed with React, that's what people love about it, is because you create these elements that you don't copy paste everywhere, right? This button is created somewhere, and you can just pull it as almost as a dependency. So that's the idea there. You write it once and you can use it everywhere. Any questions on this? The target UI we're building, you've seen my Figma files. We'll talk about it maybe tomorrow. If you have questions, come tomorrow prepared with your questions. I'll answer those, or I can answer them right now as we wrap up for the day. But a lot is defined in those resources folders. So this is really not building hard on the Kotlin code in this case. I'm going to pull this. If you look at the Kotlin code, it's very, very similar. So I haven't like made big changes to it. Oh, sorry. Yeah. But what has really, really changed are all the XML files. So all of that work of building the UI is really built in the XML, on the XML side of things. Now I've got, a Bitcoin logo, launcher background, the testnet logo, which is that green. And you'll find that now I have a lot more. So these XML files now have, like, if you look at the tree here, is toolbar, image view, text view, new wallet button, recover button. So we have a lot of those elements that are in there, and some of those are very simple recovery phrase, but then the receive, for example, is a lot more complex because it has an image view in there. They have titles, and then the address is being displayed and a button. So that's the kind of thing. And then my colors are defined into here. So my Nord theme has been added. So now my colors are usable directly using their names. So for example, we'll go into the receive fragment. And this button here at the bottom, if I'm looking at line 51, you'll find that I declare a background tint on it. And I call this @color syntax. And that says, go into my colors. And then, this is the name of the color I want to call, basically. And you can, if you look in the design, all of those that are in the code are also here. So you can like scroll down and you can search for it. So say I want to say size, maybe, right? So, text size, boom, I see it. And so I can go here and say 24. And now I've updated the size of my font. And now if I click on this button, my text size is defined here, bottom right. So I'm going to go back to 16. But yeah. And we're going to try to build this. 11:57. 3 minutes. Nice. And it might, see, it's working. Okay. So we have this wallet, and now it has the same thing as before, right? We don't have any Bitcoin features. We really just have a UI that looks the way I had them in my wireframes. And a lot of those are defined into my themes. If you look at my themes, the Android theming whole game is pretty annoying to work with at first. And so what happens is you have a lot of your elements are pulling from these default themes. And what you can do is extend those themes. So what I'm doing here is I'm creating, for example, line number 4. I'm creating a theme called theme.summer of Bitcoin wallet. And then it has a parent. And that parent is what's already been used. And then, color primary, I define it to be color night 1, and then, all those kind of things. So status bar color, and then that's how I go and I fix the colors that'll work on all apps. Another way you could do it is inside of your XML files, right? You could define on each screen, you could define a color. So I could say background, background, and then, define color Aurora green, for example, right? Then that would change my color here. So this is how you would sort of go about customizing. This is how you'd go about customizing per screen. But in general, if you want to apply themes and color schemes to an entire app, you would want them to be defined in your themes. And your themes are under my values directory. And again, we have this, this thing. Some people said the UI was cool. Thank you. I'm not a designer, but I just love good looking apps. So I always spend more time than I should on those, on just like trying to build wireframes that I like. So that's the end of the official workshop day 1.